We've been talking about sort of saying that if you have an unbiased estimator, then the value of the estimate is going to be, give or take one standard error, the value, the truth, the parameter that you're trying to estimate. So our estimate of the population parameter would be, it's the estimate plus or minus about a standard error, okay? Because the estimator is likely to differ from the population parameter value by about a standard error, sometimes more, sometimes less. Well, we're going to try to turn this into a more precise statement now, a different way of quantifying error. We were talking about quantifying error by mean squared error in the previous chapter, and then mean squared error just reduced to the square of the standard error for unbiased estimators. And we were talking about two unbiased estimators, namely the sample percentage and the sample mean as estimators of the population percentage and the population mean. Okay. Now let's think about actually quantifying error in a different way. We're really going to give an estimate, give or take some range. We're going to give some range of values as our answer rather than a particular value as our answer. And we're going to calibrate it in such a way that our procedure has a big chance of producing a range of values that includes the true value of the parameter. So the idea is something like this. Here is the true value of the parameter. So this is truth. And we're going to give an interval as our estimate. And the interval is going to depend on the random sample. So the interval sometimes is going to be way out here, sometimes is going to be in here, sometimes is going to be down here. When the interval includes the truth, the interval is said to cover the parameter value. Okay? When the interval doesn't, it doesn't cover. Right? And what we want to do is we want to come up with a rule that gives us intervals that have a big chance of including the truth. So that most of the time, for most samples, the interval is going to include the truth. Sometimes you'll get a sample where the interval won't include the truth. But we want to say, for example, that 95% of the time, the interval that we get is going to include the true value of the population parameter. If we have a procedure that does that, gives us a random interval so that 95% of the time that interval includes the truth, that's called a 95% confidence interval. Okay? So how do we do that? Right? Well, what do we know about, let's start by talking about the population percentage because we can figure out the largest that the standard error of the population percentage could be. We're going to do something really, really, really conservative. We're going to use an upper bound on the SD of the box that comes from pretending that there's 50% zeros and 50% ones, because it can't get any worse than that. And then we're going to use Chebyshev's inequality to figure out how many standard errors away from the expected value the thing is likely to be, the estimate is likely to be.